Oh hey, what's happening there YouTube? It's Brian House here for Housemade, and today in this video we are going to be building the Apollo Forge. Now right off the bat I want to just say that you are working with flammable things that are dangerous, so if you do this it's at your own risk, just understand that. And also I highly suggest that you watch the entire video before you attempt to even start this project. There's just so many little details that you want to pay attention to that are safety related, and I think it's important. Now, this video is a companion piece for anyone who bought the kit or the plans. If you're interested in doing that, you can go to my website, housemade.us, and pick up the plans or the kit. And in this video, we're going to cover the air delivery system, the propane delivery system, and assembling the box and the insulation, all the pieces and parts that you need to make that happen. And in another video, I'm going to cover building the ribbon burner. That's just going to have its own separate video. So in this video, we're going to use the house-made ribbon burner that we make right here in our workshop. Anyway, guys, let's get started. All right, so let's talk about what you get in the kit. You get the top and bottom pieces, the non-burner side, the burner side, the front and rear panels, 2 doors, enough Castellite 30 Li plus to fill those doors, and all of the hardware. So essentially everything to build the steel box, the doors, and some refractory and hardware and all of that. Now keep in mind that we do ship our doors flat like this, and we're going to bend them into shape right here in the workshop and then fill them with refractory. It's kind of a fun project. Now before we start assembling the box, we're going to go ahead and drill out these 4 holes. That's going to be a drill bit size of 5/16, and then we're going to tap them 3/8/16. These are for the bolts that are actually going to hold in the ribbon burner, okay? And it's just easier to do this now before everything is assembled. Okay, so now that we've got those holes drilled and tapped, we need to bend these tabs out at 90 degrees. And the best way I've found to do that is to just apply some heat and use some brute force. Hammer, some channel locks, you know, whatever you got at your disposal, you just need to bend these tabs out at 90 degrees. 1 down, 1 to go. You must apply heat. If you don't, you'll break the tabs, and it's not the end of the world. You can always weld it back together, but yeah, little brute force, little heat, get it done. Now I'm going to build it on this stand right here. You have a couple of options as far as how you want to do this. You just have to understand on one side of this you're going to need clearance for the downpipe for the ribbon burner and the actual blower itself. But for this, we're just going to go ahead and build it right on this mobile stand that I've got here in the shop, and I'm going to tack it to this plate so I have a nice rolling forge. All right, so now we can start assembling the box. We're going to put 3 of the 4 walls on, and they'll just support, the tabs will just support the parts, so you can just lean them up like that. We're not going to do the front yet. We're just going to place these in here because we're going to lay some Innswool in here. We've got to cut that, lay it in. So this is Innswool paper 2300, and this is the barrier that goes between the steel box and the insulating fire brick. I feel like this is a really important component to having a long-lasting forge because it just protects the steel. You need about 4 feet of it. We sell it on the website. You can add it to your kit. You need about 4 feet by 18 inches. So we're going to cut that and lay it into the box. All right, we've got our Innswool cut, and we're going to lay it down inside. Doesn't have to be super precise just yet, so you can kind of fold it over. Now let's talk about the rest of the insulation. This is insulating fire brick. This is soft fire brick, and I buy these on Amazon. We have a resources page on our website that will direct you to the right size and the right type of brick. But these are readily available all over the place. You can find these online everywhere. The one thing you really want to pay attention to is the temperature rating of these. Now these are rated for 2700 degrees Fahrenheit because we're going to be using the Apollo to forge weld steels, making Damascus and pattern welded steels and all of that. And most people do that type of work around 22 to 2400 degrees Fahrenheit. So I like a little bit of a buffer zone just in case the forge gets a little warmer than that. So these are rated for 2700 Fahrenheit. Now we got to do a little cutting. These are really easy to cut. You can cut it on a traditional bandsaw or with a handsaw. So one of these needs to get cut in half, and another one needs to get cut into thirds or about 1.25 inches, just a little bit over 1.25 inches. Now the floor of the forge is hard fire brick. This is slightly different than the soft fire brick. This actually is not insulating. And the reason why we use this is because it's nice and hard and it can stand up to the abuse of you setting hot steel on it. All right, let's start laying in the fire brick. Let's start with the floor. And at this point, we can cut the hole for the ribbon burner out of the innswell. Innswell is easy enough to cut with just a standard knife. Now we're going to lay that third of a brick down right below the opening of the ribbon burner. And the fire brick that we cut in half goes on either side of that. So it looks like that. 2 more on this side. We'll start laying in the roof bricks. We're going to thread in the 4 bolts that are going to hold on the ribbon burner. And we can put the faceplate on. And at this point, we're going to grab a couple of bar clamps, okay? And this can get a little fiddly, so these bar clamps are going to assist us in the final steps of assembly here. What you want to do is you want to hold everything together as much as possible with a little bit of pressure, okay? And you can see where this gets a little fiddly. So get your bar clamp set up. And it doesn't need to be a ton of pressure, okay? It just needs to be enough to keep everything kind of in place like that. And I put one in the front and one in the back. Okay. And now with those clamps in place, it's really easy to slide in the ribbon burner. Slide it right into the opening. And then line everything up on the inside. And then tighten down these bolts. You can just finger tighten these just to kind of keep it from falling out. Now with that ribbon burner in place, you can see that's important because these bricks need somewhere to sit. If that ribbon burner is not in place, and you do that out of order, these bricks won't have anything on that one side to rest upon. And that's kind of the beauty of this design, is that if any of this goes wrong and you need to replace any of this, you can see how simple it is to open it up and do repair work. All right, so now that we've got that done, we can fold down our innswell. There's a little bit of overlap there, and that's okay. And we're going to grab the lid and set it on. Try to get it lined up as much as possible. Some of the tabs may not fit in right away, but that's okay. We're going to put in the hardware, and then as you put in the hardware, you can kind of clamp things together and make it fit. All right, now we can start taking these clamps off because we're in a position where nothing's going to fall apart. But we might need a little bit of clamping force forward to rear. So I'm just going to take this clamp, and I can suck in where I need it to, and then do some more tightening down of the hardware, and that'll get us where we need to go. Now, one of the things you're looking for in here is that all the bricks are lined up, you know, for the most part, that everything's kind of a nice tight fit. And I can't stress this enough, this soft fire brick, it's soft. It will crack on you. So you really want to respect it and be gentle with it. You know, it will break. The good news is you could probably stack it in there broken and it would perform the way it should, but it's just not ideal. Now, if you do have a brick that needs to slide over, you can grab just a simple, clamp like this and use the soft, gentle clamping force to kind of move something over if you need it to, or something's out of alignment at the top and you want it to kind of just squeeze over a little bit. You can see how I can make that happen just with a quick clamp like that. And then the final step is to tighten these down, but you don't need them really super tight. What you'll notice is even when it's loose in there, these bolts aren't doing much other than supporting the burner if you ever needed to take it apart. The fire brick is designed in such a way with the sandwich construction of the steel to support this without really any tabs or bolts or anything. They're just really here for the assembly, and also, just as a security measure, if something were to flex and change because of heat or temperature difference, these bolts will support the burner from falling out. That's an important piece to this because you're going to have a pipe that comes down and a burner that's hanging off of this, so it needs a little bit of support. So you don't need to tighten these down and really crank on them. You just really need to get them snugged up to the burner itself. Hey, congratulations, the box is done. So let's move on to the doors. All right, so here's the flat pack door. This is got tabs and little slits in it to assist you in bending this to shape. I highly suggest you watch this section a couple of times and even follow along and pause the video while you're bending your own door, because there's quite a few bends and you have to do this in order, otherwise it will not go together correctly. Okay, so take my advice, trust me on that, and let's get started. So the first bend we're going to do is this bend right here, the top bend, and then we're going to work our way down. Okay, so this top bend right here, I've got a work surface that's nice and flat, and I'm going to set the door on its face. So the logo is backwards, and I'm going to line up this slot right here with the edge of my table. Grab a couple of C-clamps, and I'm going to clamp down the steel because we've essentially are going to create like a mini brake here, and we're going to use a hammer and we're going to bend this over. I don't own a brake, and I'm assuming a lot of you don't either, and so that's the reason why the design is like this. So now we've got the tab, or the slot, lined up with the edge of the table, so I can just tap this down, okay? $90 degrees, simple. And now we're going to do the exact same thing on this second slot. So you can see here, this is operation 1. And operation 2 is going to be doing the exact same thing on that slot. So that's operation 2, and this tab is actually meant to be down flat, so we're just going to tap that into place, just like that, okay? Now you might adjust this later, but that's what it should look like at this stage. So 2 bends, 90 and 90, same direction. The next bend is going to be this one here. We're going to lay this flat like this, just like the other 2 bends on the table. Clamp it down. So now that this is clamped down, we're going to tap on either end and bend this down 90 degrees. You can see I'm evenly distributing my hits between the 2 sides. So now, that's what it looks like, just like that. And if things are off just a little bit, it's okay, we can adjust them later, all right? Now this is the most complicated bend of the entire door, so really pay attention here. You're going to lay this flat like this with the tab sticking up towards you. You're going to line those slots up with the edge of the table. Clamp everything down. And I like to use some sort of chisel or some sort of, I don't know what this would technically be called, some sort of punch of some sort to make this bend. And it's got a little bit of a wider tip than a standard punch. And that's because I'm going to be applying pressure into this corner because I want to bend this down, but I don't want to deform this other piece. So when I put this here and I apply pressure with a hammer, I'm able to push it down and bend it into shape. So just take your time. Now you can come in and push this tab back down, straighten things out a little bit, and get it looking like that. And there is quite a bit of adjustability in this, so don't worry too much about it. But again, I can't stress enough, that was the hardest bend that we just performed. The rest of these can be done in a vise. So just take your door, do the bottom first, line up the tab with the top edge of the vise jaw, tighten it down, grab the whole door, bend it into place. And the two side walls here. Took me about 5 minutes. I will say, took me almost 3 months to figure out the process, but now that we have it down, it definitely comes together quick. Last is we got to bend in these tabs, and I use just a standard punch to do that. Take your punch, put it right on the center, top center of this, and punch it through. And what those tabs are for is when we fill this with refractory, the refractory pours around those tabs and keeps the steel from separating from the refractory. There's tabs on all sides, by the way, so you got to do 2 for each side. So we went from this to this. About 5 minutes. Take your time, watch the video again and again, just do as I do, each step, pause the video as we go. When you're done with the first one, the second one will seem easy cheesy. All right, so now we got both doors bent, all the tabs in, everything looks good, and you're thinking, how are you going to pour refractory into this? It's full of holes, right? Well, real easy answer to that is just some blue painter's tape. We're going to seal this up and make it, it doesn't have to be super watertight. It just, you know, the refractory is like a mortar, so it will leak some water, and that's totally fine, but we're going to seal it up in blue painter's tape. by far the best thing I've found. I've tried masking, I've tried duct tape, and both of those leave residue or are hard to remove. But this stuff works perfect. All right, so notice how I took my time doing that. I know this seems kind of arbitrary, but it really isn't. The more time you take to do this and really seal things up in here, the easier it will be to clean up once everything is dry and you remove the tape. So you can see I put the tape all the way up to the top of each corner, and then I sealed it with my finger. I made sure that everything was nice and sealed. That way when you pour on the refractory, it's fairly watertight. Okay, so now we got both doors all sealed up and ready to pour the refractory. So the refractory that we use in our kits is Castellite 30 Li+. And this is rated for 3,000 degrees Fahrenheit. It's a castable, pourable refractory. This is what it's designed to do. And that's what I use to make the ribbon burners, and that's what we're going to use to fill these doors. Now, you do need to measure your refractory and your liquid, your water, by weight. So you need some sort of scale. A food scale will work, and that's just fine. That's what I use, just a standard food scale. I use like a mason jar to measure my water. I always wear full PPE when I'm doing this, right? Dust mask and rubber gloves. It's just a good precaution. I'm working with this stuff a lot, so I take that precaution, and I think you should too. I use a kind of a crazy looking spiral thing I hook up to a drill to mix it. That makes it easy. Big old spoon and a bucket from wherever. So let's get that going. All right, so here's the consistency that you're looking for. It's gonna seem really dry. It's not quite like what you would think with a cement. So this is 80 ounces of refractory with a little over 14 ounces of water, like 14 and a half ounces of water. And you have to weigh it. You can't use a measuring cup. All right, now we're gonna scoop this into these doors using that big spoon. Now here's a trick. Just grab an old Sawzall with no blade on it. That'll kind of work all the air bubbles out, then you can use your spoon to kind of smooth everything out again. You'll have to kind of do this back and forth a couple of times just to get good consistency. All right, we'll let that one sit for a minute. Do this door here. With refractory, you have about a 15-minute working time. Might need to steal some from this other door just to kind of get us where we need to go. Totally legal move. You can do it. All right, so the refractory is poured in. It's looking good. Got a nice surface finish on that. And this is going to take about, I'd say about 3 days to cure. You know, don't push it too much, because if you light the forge and this still has moisture in it, then you're going to have a bad time. The moisture will bubble to the surface and break the refractory. So let this sit for about 3 days. Now let's take a quick look at the support rod that holds up the doors. You're going to have 2 of these in your kit. They're 1/4 inch diameter steel rod, okay, and nothing special. But you want to be able to stop these from sliding left to right in these holes here. One side we're just going to bend over. You just use a hammer and an anvil or something strong where you can bend over the end, you know, just turn it about 1/4 inch or so. That will stop the one side from sliding. And then the other side, I like to just use a die and a 1/4-20 die and create some threads on the end of this rod. And that's a really easy process to do. Just take your time, use a little cutting oil, and then you can put a wing nut on the end, and then that way if you ever need to swap out your doors or take them off, you can remove them quite easily. All right, so let's move on to the air delivery system. Everything you see on my table here is a part of that, and if you're looking for pieces and parts, there is an Apollo Forge resources page that has links really conveniently laid out for you so that you can buy all these things. So this is the blower that I prefer. I get this on Amazon. It is a 440 CFM centrifugal fan. I tried 3 different versions of fans when I started this prototyping process, and this one by far exceeded all of my expectations. This was a recommendation from Mark Krause. So if you know who Mark is, you'll know that when he says something, you need to listen to it. When you're working with forced air burners, all of those things, he is an expert, and he was the one that gave me the tip on the centrifugal fan. So we then developed a funnel that would actually take this 6-inch opening and funnel it down to a 2-inch pipe thread. This is something you can purchase from Housemade, or you can add the STL file to your plan set and you can print your own. That slides right over and then is affixed to the fan using some self-tapping screws. You'll need a gate valve. This is just a standard 2-inch brass gate valve. I get these on Amazon. You'll need a downpipe. This is a 12-inch version, which is also 2 inches. I've used up to 20 inches, and those work fine too. The length didn't seem to matter much. And then a 90-degree fitting that will turn 90 degrees and go into the ribbon burner. So let's get this all set up. We have a little bit of work to do. We need to drill and tap a hole into this downpipe so there's an input for the propane delivery system. So what I like to do before I drill and tap the hole into the downpipe is dry fit all of this so that when it's tight, all my gate valve, where the propane delivery system sits, this little control box for the fan, all of that is in the right position, and you can't really determine that unless you dry fit it. So I'm going to go ahead and do that now. We're going to put the gate valve on top of the funnel, tighten it down. Doesn't need to be super tight, all right? Just thread it up until it's nice and snug. Do the same with the downpipe. You can kind of start to feel when the threads are getting tight. You know you're getting there. Okay, and so when I'm looking at this, I know that the way it's going to sit on my forge, I like this to be pointing away from the forge. I like this to be pointing or in alignment with this particular part of the control box. So I've got all of that, and then I'm thinking, okay, well, as this is threaded into the ribbon burner up here, we're gonna, if you add the 90 degree, spin this around. Got that where I want it. Spin on the 90 degree. Kind of do the same thing. You have a little bit of play with this, not much. So what I like to know is that when this is all together, that the gate valve is pointing that way, and this 90 degree should be pointing the opposite direction. Is that possible? I think it is. Yeah, we've got enough room there. I'm not going to tighten it down too much now, but yes, that's possible. So with that current configuration, I'd like the propane delivery system, which we haven't assembled yet, but I've got one here. When it sits on here, I want it to be down and away somewhere in there. Now the hole needs to be drilled about 1 inch or 1.5 inches above the gate valve. It doesn't really matter too much, but it needs to be towards the lower end of this downpipe, okay? And when I'm using the forge, I'd like to think, okay, my hand's gonna be here a lot. I'm also going to be adjusting the propane with the needle valve, so I don't want those to interfere with each other. So those are the things I'm looking for, okay? And I think that makes the most sense, about right there. So I'm going to go ahead, make a mark here, and so I'll know that that's where I want to draw or drill my hole. And then I'm going to line this up here And I'm going to go ahead and put the screws in for the self-tapping screws in for the funnel. All right, so now we're going to drill and tap the hole that we need for the input for the propane delivery system. I've got the mark on my down tube, and I'm going to use a small punch just to make a mark there, and then we're going to drill a 7/16 inch hole and drill a 1/4 18 NPT pipe thread. If you're looking for the tools to make this happen, they are linked on our resources page. So now we got our drilled and tapped hole in our down tube. We're going to put this in a vise, tighten it down. Doesn't need to be super tight, but tight enough to where we can thread on the 90 degree. This is the first step of the final assembly of the air delivery system, and we're doing this in a vise because we want this to be the polar opposite of the hole. So this should be another 180 degrees. And you can see it's getting tight, so I just use, you can use a pipe wrench or whatever, I just use something for a little bit of leverage, just a gentle bit of leverage here, and turn until it's where you want it. Okay, so now we've got our 90 degree on our down pipe. We're going to thread this into the ribbon burner. And I don't thread it all the way in. I leave a little bit on an angle just so I can get the blower and the gate valve threaded on without it running into anything. Just like that. And then you can push it down into place. All right. I love it. All right, let's really quickly go over the propane delivery system. All these parts are readily available, most likely at a big box store, Home Depot. I buy all of it on Amazon, and there's links on the resources page to all of this. All of these are 1/4 inch NPT. This is a ball valve. This is a needle valve. Here's a nipple, a corner, and then another nipple. And it's really that simple. Now, the one thing you need to know is you got to put some Teflon tape on here, and this isn't any normal Teflon style tape. This is for propane. This is PTFE, which is, you ready for this? Polytetrafluoroethylene. It is rated for gas, and it won't wear away like a standard Teflon tape will. So you need PTFE tape, and there's links on the resources page to find this stuff. You can buy this at Home Depot or Lowe's or whatever. And we're going to string all these together into this configuration. Let's do this right now. There's an arrow on this needle valve here. And so you want to make sure that you've got that arrow in the right direction for flow. So it looks like this. This is a real rudimentary version of a propane delivery system that allows the fuel to flow through. The ball valve is for safety. You can turn it on and off. The needle valve is for adjustment, and then the propane flows through here and into the downpipe. This is a very simple way of doing this, and it works fantastic. Now, there are a couple of options that I'd like to see you put on your forge, and one is a normally closed solenoid, and you can plumb this right into this entire scenario here. It's 1/4 inch MPT. There's links on the resources page, and then you can wire this into your fan or a switch. And what this does is, because it's normally closed, when there's no electricity put to this, the valve is closed. And when there's electricity flowing through it, the valve is open. And what that means is, if you were to be forging, you would lose power, this would close off the flow of propane automatically. I love these. They're great. They're inexpensive, and I think it's really worth doing. It's an extra step, but it's for safety, and I think it's important. Now, another piece of optional equipment is a quick disconnect for this. You can thread this on, and then on your line for your fuel, for your propane, just like an air quick disconnect, you can plug in your propane. When you're done, you unclick it, and this is rated for propane. This has got a little valve on it, so it's a little safety valve. So you click into place and then slide this over, and that means the flow of propane can happen. These are great because you don't always want your hose hooked up to your forge, or if you move your forge around, all you do is flip that ball valve shut, pop it off, and now your hose goes away. Last but not least, this is the hose I prefer. It comes without the quick disconnect, so I'll show you that. This is the hose I prefer. I like it because it's got a regulator on it, and it has a little PSI gauge. Now, remember, when you're working with propane and ribbon burners with this size orifice, a PSI gauge isn't going to really fully tell you what that pressure is, okay? Because it requires back pressure, and that opening is so large that there's not much back pressure. So these aren't really meant for an exact measurement so much as I look at them like more like flow. I see it like a flow meter where I can look to see, and as you're using your forge, you'll get to know it better, and it'll kind of make sense to you, like, hey, I'm running at 3 to 5 psi for forging temperatures, and then to maintain that temperature, you're going to run at like 1 psi. Now, does that mean that you're actually running at 1 psi? I don't think so. I think that it's just a means to see your actual flow. So let's get this hooked up to the down tube. All right, so we've added a bit of PTFE tape to this joint here, and we're going to thread this in. Nice and tight. Make a minor adjustment here. Get all my dials and knobs and everything where I like them. And the final step is to take the blue tape off of the doors and hang them into place. Clean them up, you can use a little bit of 220 sandpaper. All right, so real quick, let's talk about the propane cylinder I use. This is a 40-pound propane, standard propane cylinder. You can get this at pretty much any propane supplier. I do not use a standard grill style propane tank. They're just, they have issues with them getting cold and freezing over, and there's a whole science behind liquid propane and how it flows, and then it gets cold if it flows too fast. So I go with a 40-pound cylinder because it just is reliable and it doesn't freeze over on me. So this is what I suggest you get for your forge. Now let's hook up the propane. This is the quick disconnect I was telling you about earlier. It has a little valve on it so you don't mistakenly plug it in while it's running. You also have a valve here, which is a safety feature, and a needle valve. You want to make sure all of those are closed before you connect this up. And this guy here won't let you hook it up with it open. You can't actually do that. There's a safety functionality of this thing that won't allow that. So let's go ahead and click it into place. The next step is to plug in the fan, the blower. So we're going to power that up. So now we're going to turn on the propane cylinder at the tank. I'm going to open the ball valve. And at this point, my needle valve is still closed. And I'm going to slowly open the needle valve, light my torch. Now we got it lit. And I can already see by the amount of dragon's breath coming out of the front of this is that we're running a little rich, so we're going to turn the propane down using the needle valve. And you'll start to see the flames adjust. That's why the needle valve is important. You can see that beautiful curl inside of there. Getting close. Close the gate valve just a little bit. A little less propane. Maybe a little less air. It's kind of a fine balance here that we're looking for. You might notice a little bit of smoke coming off of the components like you see here. There's just a little bit of burn off. That's totally normal. That'll go away after a little bit. What I'm looking for is that the flame is off the surface of the ribbon burner just slightly. We're getting really close. And the first burn of the forge should be not a weld heat. You should just have a low heat. About what we're looking for. We're going to let this go ahead and warm up slowly, and eventually this smoke will stop coming off of the ribbon burner and we'll be good to go. One of the other things I really like about the Apollo Forge is how quiet it is. When I used Venturi burners in the past, I could barely talk, and I'm standing right next to the forge right now, and you can hear it's just a nice quiet fan sound, and it's not overpowering. Right now, to give you a frame of reference, our dial says 2 psi. Now, to safely turn off the forge, just switch off the ball valve, and that will cut off the flow of the propane, okay? I also, at this time, like to go back and turn off the propane tank, just so I can ensure that there's no flow of propane. Then I'll reopen the valve and burn off that last little bit of propane. Close the valve on the quick disconnect, and remove the quick disconnect from the propane delivery system. I then let the fan blow for about 5 minutes, and what that does is it cools off everything on the inside and lets the fan fully dissipate all the propane. Then after about 5 minutes, you can go ahead and just unplug the fan. So a couple things about the plan set and the kit. If you buy the plan set, there's an option to get the 3D printed files, like the mold for the ribbon burner and the funnel that connects the blower to the 2-inch pipe system. That's optional. Not everybody wants to 3D print their own stuff, so we just made it an option. And if you buy the kit, it's actually included. So when you buy the kit, you get PDF document that lays out how to assemble it and how to build it. You'll get the 3D printed files. That's all just comes standard. There's DXF files that are included in the plan set. Those come standard. So if you have a laser or a plasma cutter and you want to cut those out on your own, the DXF files are included for the doors, all the plate steel parts and all of that. So, but there is an option that you can download a CAD file of the Apollo Forge as well, so you can see all the pieces in Fusion or in step files. So that's kind of a cool thing. We do that with the Revolution project, where if you want to see how I built the thing in Fusion or in CAD, you can buy those files and download them. That's kind of a learning tool. And then also, I gotta bring this up again about safety. You're working with propane. It's explosive. It's a gas. It's, in my opinion, one of the safer fuels to be using, but just be very aware of it at all times. Never get relaxed around a forge. Never leave your forge unattended. There's just all these things that I really want. I can't teach you everything about safety and fire and all of that, but I've seen a lot of experienced people lose their shops, like guys who are blacksmiths and knife makers, and they've lost their entire shop, sometimes their home, because they just let their guard down one time. So the safety features, like the normally closed solenoid that I talked about when putting together the propane delivery system, I really do feel like for the little bit of time that it takes to wire it into the fan and to plumb it in, and the $20 that thing costs, it's just a no-brainer. You should put it on this device. You should just do it. I didn't put it in the video because it's not 100% necessary for the machine to run. But I will say that I think it's really important, and you should look into that. And I'll make a video down the road about how that works, and it's super simple. It's just a 110 device that, if there's power applied to it, it's open. If the power were to go out, it closes and it shuts off that propane flow. And why that's important is because you don't want propane just dumping into a system without airflow happening, because that can create an environment where you've got propane spilling out onto the floor, or if it's not igniting inside of the forge, it's just a big safety problem. So I really think you should have one of those. And also the quick disconnect, that's just such a simple little thing that costs just a few bucks. But again, it's another layer of safety, so you're not always leaving your hose from your propane tank connected to your propane delivery system, because that just saves, that's one extra layer of protection, right? If it's not hooked up to anything, it can't leak, and that kind of thing. Remember that the doors and the front and rear panels of this are sacrificial, meaning they will eventually wear away. And I don't know so much about the front and rear panel. That'll probably take a long time for those to disintegrate, or at least cause a problem. I think you got years on those. But the doors are probably something that you're gonna have to, depending on how much you use your forge, right? But they'll just understand that those are not like permanent things. The second you light your forge, it's trying to destroy itself. And the whole point of the Apollo Forge was to create something that was easily repairable. These other designs of these forges are great, but if something were to crack or fall apart, then it's a full dismantle, and you have to tear everything apart and replace the interior, the lining, and all of that. But with the Apollo, you can just replace one $12 fire brick, or you can replace the front or rear panel or a door. It's very modular, right? So that was the concept here, the problems we're solving. And it's immensely insulated, meaning the bricks that are in there are holding the heat and keeping things efficient. I get that question all the time. Is a ribbon burner really more efficient than a Venturi burner or an atmospheric burner? And in my opinion, I don't think so. I think that it's more efficient in this particular application because the fire brick, the insulation is holding more heat, and you get a more even heat with a ribbon burner. Remember, the reason why we place that ribbon burner on the side and up near the top, so it's pointing and shooting into the sidewall of the forge, is because we want the forge to heat up evenly. A lot of these forges with the burners pointed straight down on the work piece, what they're doing is they're creating hot spots in their work, which is how you get cold shuts in your Damascus and your pattern welded steels, how you leach carbon from your high carbon steels. So we are solving that problem. Yes, it might take a little longer for your steel to heat up, but once that forge is evenly warmed up all throughout, you have a furnace now that's burning at whatever temperature you'd like it to, and that's a much more efficient way to use the fuel than, say, just trying to heat up one little tiny piece inside of a forge. That for this particular application just doesn't make a whole lot of sense, and I think that this is going to change the way people forge things from here on out, and I'm really proud of the design. So thanks for your interest in it. And by the way, so the doors in the front and rear panel, that will be a replacement part that you can just purchase from us or cut another one, right? If you have the plans, you can just go out and cut another one and out of a piece of scrap steel if you have to, and swap it out and put it in there. So anyway, guys, I truly appreciate your interest in the Apollo Forge project, and if you'd like to pick up a kit or the plans, you can go to my website, housemade.us, so you can buy those plans and get started building and forging. As always, guys, I hope to see you on the next video and the next project. My name is Brian House, and this has been House Made.